Okay, problem 718. The equation e to the minus f times f prime equals 2 plus tangent of x, together with the condition that f at 0 is 1, define a one-to-one differentiable function in this interval, minus pi over 4 pi over. Okay, so we have this equation. Let me write it here, for instance. E to the minus f prime equals 2 plus the tangent of x, and we have the initial condition f at 0 is 1. Okay? So this is a function, as we see, this is a differential equation regarding f, and yeah, don't bother about solving this, so we're not going to be able to get an expression for f, but it doesn't matter, okay? It doesn't, with this information it's enough to solve the problem, right? So if we call g of x the inverse of f at x plus 1, calculate this limit, okay? So we have the limit when x goes to 0 of e to the x minus e to the minus sine x divided by, and let's write directly f minus 1 at x plus 1, right? So what's the limit of this? This is 1 minus 1, 0, and then what's the limit of, what's the inverse of f at 1? Well, if f at 0 is 1, the inverse at 1 is going to be 0, right? We take the inverse here, and the inverse composed with f is going to be the identity, so we have this, okay? Remember again, you think about how inverses work, this is not so hard, right? So this is 1 minus 1, 0 divided by 0. So again, this is one of those limits in which we can apply, or we want to apply, L'Hopital's rule and see what happens. Okay, so then we have e to the x plus the cosine of x times e to the minus sine of x. Okay, so this is going to be 2 now. 1 plus 1 times 1, 2. And the derivative of f, the inverse is 1 over f prime at f minus 1 of x plus 1. Right? F minus 1 of x plus 1, we've seen that the limit of this is going to be 0. So this is going to be the same as 2 times f prime at 0. Okay, this passes multiplication here, multiplying here, sorry, and this is 2. So 2 times f prime at 0. Okay, this is the value of the limit. But what's the value of the derivative? For this, we need to apply the definition here, right? So we have, let's solve for f prime. So we have f prime of x is 2 plus the tangent of x, all of this multiplied by e to the f of x. So now f prime at 0 is going to be 2 plus the tangent at 0, which is 0, times e to f at 0, which is 1. So e. So this is the same as 2e. So 2 times 2e is 4e. And this is the limit that we wanted.